from 8.
The Radio Wammo Breakfast.
Good time now to stare into the night sky with a weekend coming up and hopefully some clear skies where you are. Dylan Storey joins us. Good morning, Dylan.
Good morning.
Morning.
It's a good time to be looking at the night sky.
Certainly, well, it's getting better and into the winter months where things get a little bit crisper and a little bit clearer. But today, first up...
Yeah, they do.
Yeah, they do. First up, we're covering Mercury because for the first time there is a spacecraft that's getting close enough to get some good pictures.
Yeah, well, we've had spacecrafts close before, but today is the first time that we'll have a spacecraft in orbit around Mercury. So it's another first for space travel. All the other photos we've got of Mercury are just from basically sending a craft to fly really close past it and take a whole lot of pictures really quickly and then disappear off into the sun or wherever.
And what are they calling this intrepid traveller?
It's called Messenger. And because astronomers love acronyms, it's got something like the ME stands for the something something, and it's all made up of all these different words. But Mercury, of course, is the winged messenger from Greek mythology. So I think they kind of make these acronyms say what they want them to say.
And how long ago did they send it up?
Well, that's the strange thing. It was launched in 2004, and it's been travelling to Mercury all this time, so 7 years. And you might think, why has it taken 7 years to get to Mercury, which is one of the closest planets? Well, the answer is because it's an inner planet, and it's very hard to get the orbital mechanics right to actually get into orbit around the planet. That's why we've never done it before.
Huh.
Because if you think of outer planets, you can just basically fling the spacecraft off in a same Mars or Jupiter, and fling it off in a collision course.
Yeah.
And 7 months or 5 years or whatever later, it'll get there, and if you correct your trajectory and enter into orbit. But because this is an inner planet, you've kind of got a curve that you've kind of got to do a really delicate balancing act with the velocities and get it in exactly the right place and the right speed and everything with it's got to balance the gravity from the sun and all the planets, so it's a very delicate maneuver, and it's actually been round. It's done a lot of orbits of the sun and the other planets on the way there, if that makes sense. So it's done. First, it's done 2 Earth flybys, so do a lap of the sun and then fly by Earth, then fly by Earth again. Then it would change each time it would go past Earth. Would get caught in the gravity slightly or use the gravity to slow it down or speed it up, and so it heads in again so that next time it can curve around. And then it did 2 Venus flybys, so it got photos of Venus and had its course altered by Venus's gravity. Then it's done 3 Mercury flybys since 2008, so it's close flybys and using that gravity to correct its orbit so that it's circular enough so that next time. And so after the 3rd pass of Mercury, then finally it'll arrive at Mercury today. It's got its velocity reduced enough that the thrusters will be able to get it into orbit around Mercury.
We really are pathetic, us ancient humans, aren't we? I mean, when you think about it, our future people will be going like, it took you 7 years, and you went where to get to Mercury? You pathetic.
And you went to the moon 40 years ago. It took you 7 years to get to Mercury. But I actually had it explained to me once by one of the mission controllers when I was at a conference, and they really sort of managed to explain the complexity of getting this thing into orbit. Is this, if you imagine something swinging round, which is basically what it's doing around the sun, and having to have it so delicate, it's got to have exactly the right speed at exactly the right time to meet up with this tiny little thing. So, all going well today, which it should, and we'll have a craft in orbit around Mercury, and that means we can know a lot more about Mercury. We've only had about 30% of its surface photographed before.
What do we need?
Be able to get a look at.
What do we need to know about Mercury?
Mercury's the densest planet in the solar system, so we want to know why is it so dense. What's going on with the core that makes it the way it is. We want to know about the geological history that's formed the different features on the surface. something that I think is probably quite important is we want to know the nature of Mercury's magnetic field, because Mercury has a magnetic field, as does Earth, which was one of the things that allows life to exist here. The magnetic field shields us from all the bad radiation from space. Mars and Venus don't have magnetic fields, so they've got kind of inert cores in a lot of ways.
Yeah.
So they, if we were living on Mars for some reason, we wouldn't have anything to protect us from a lot of that radiation from space. So it's the information we find out from Mercury is going to be important in finding what makes a planet get a magnetic field. Mercury's poles are areas of interest because even though it's the closest planet to the Sun and it's getting baked by the Sun every time that side of it faces the Sun, there are areas on the poles which will be down in craters which actually never see sunlight. So like the Moon, like it was discovered recently in those similar areas on the Moon, there is actually water, there's ice. So could there be ice on Mercury even though it's really close to the Sun?
Any possibility of life?
Virtually none, no.
Can we set up a penal colony on Mercury?
Yeah. Maybe in the future.
That's what I'm talking about.
Maybe conspiracy theorists will be saying this is what they're actually doing the mission for, is to establish penal colonies or one world governments on the surface.
Certainly
of Mercury.
it'll sort out our justice system. Okay.
Well, it'd be punishment because the surface goes between about 400 degrees on the day side and about minus 180 on the night side. So that'd learn them, eh?
Sounds like hell. Okay, well, we look forward to seeing those pictures and learning more about Mercury. Now, tomorrow, big moon rising?
Well, not really, no. Close moon rising.
So what does it mean?
Well, tomorrow is the closest approach of the moon in quite a while. So if you imagine the moon's orbit as being elliptical, it's basically an oval, so it comes slightly closer, comes 10% closer on average at its close pass by, which is called perigee, than it is at its furthest point, which is apogee.
Yeah.
And the distances of the perigee and apogee vary by a few thousand kilometres, which is kind of only a tiny percentage of that 10%. So tomorrow's perigee happens every month. It comes closer every month. Tomorrow's perigee is going to be slightly closer than any other perigees for a while.
So does it mean we get a better gander at it? We can see more features on the moon?
If you're taking photos with a telescope with a fixed sort of field of view, you might notice it fractionally bigger, but with the human eye, you're going to notice absolutely nothing. It's not going to appear any bigger. This sort of ties in a lot of the information that's been going around this. It ties into something called the moon illusion, where sometimes when the moon's on the horizon, it seems to be bigger than it really is. And it does cause all sorts of misunderstandings. I've had people come up to me and say, "Oh, the moon was so big the other night; it was taking up like a quarter of the sky." I'm thinking, "Oh, really? Oh, no, it wasn't." But it's if you measure the diameter of the moon when it's on the horizon, when it's looking really big, you get something like, I don't know, your little finger stretched out at arm's length, or you could get some sort of measuring device and measure how much area of the sky it's taking up.
Yeah. And
then measure it when it's directly overhead. It'll be exactly the same. So it is just an optical illusion.
Okay, all right. It's optical illusion, but it's also sort of real in that the atmosphere is magnifying it somewhat.
No, it's not.
No?
That's a sort of false explanation.
Okay.
That often goes around. The accepted theory of why it appears bigger on the horizon is that the human mind has difficulty perceiving the sky as an even hemisphere. So we sort of perceive it in our special controls in our mind, perceive it as more like a shallow dish going over us.
Oh, okay.
And so when we see the moon overhead,
yeah,
we're in our mind in our mind's background processing, we're expecting things overhead to be closer.
Yeah.
So when we see the moon this side, we think it's further than when we see it on the horizon, where we're perceiving it as being further away.
See, that'll be another thing that the future humans will go, you stupid ancients. You silly people.
Maybe if they've kind of genetically modified that perception out of the human mind, which could happen. Like, you could bolster the human mind to better spatial recognition capabilities or something.
Yep.
If the atmosphere distorted the moon, then you'd be able to physically measure a different diameter of the moon on the horizon to overtop. But if you measure them, they'll be exactly the same.
Right. All right. We'll go and see the moon over at the Auckland Stardome Observatory, and we look forward to talking to you, Dylan Storey, next week. Thanks very much.
Yeah, they've had telescopes on the moon for the last few nights, and it's been looking spectacular. Also, Saturn's really, really good to see in the night sky, so get along to the Stardome.
Cool. Cheers. We'll see you next time.
Thanks, Wammo.
Dylan Storey there. It's 5 minutes away from 8 now here.